Let's have a look at this idea of polynomial division. Basically, it's long division. You may remember from, when would that have been? Infants, primary, somewhere around there when you first do long division. But it's the same idea. With numbers, we usually say when we divide and do that long division, it's always two numbers multiplied together plus a remainder, you might remember. It's still the same idea of polynomials, so just to define each of the polynomials. So AX we call the divisor, or what we're dividing by. QX, quotient, or the answer we write above the line. RX, the remainder. A couple of things. The degree of the remainder is always less than the degree of divisor. Because remember, we're not talking about numbers here, we're talking about pieces of algebra. So how do we know whether we keep dividing? And it's all to do with the degrees of the polynomials. If that remainder has a higher degree than what we're dividing by, we can keep going. Okay, it's a bit trivial. QX and RX are unique. That just means they're different. Because if they were the same, then you could factorise them and come up with a different expression. Well, let's do it by means of example. A very old one, 1998. So they want us to find the quotient and the remainder. We're going to divide this by x squared plus 1. Now, I always reckon when you set these up, you include the missing terms, otherwise you can muck it up real easy. So whilst the question didn't have an x cubed, I'll put naught x cubed in there, and the same with x. And when we're doing our division, remember, it's the powers we're dealing with. And really, you're just looking at the leading term. So x to the power of 4 divided by x squared would be x squared. And then we multiply out. So x squared times x squared plus 1 is x to the power of 4. We don't get any x cubed and an x squared. Then the next step is to do a subtraction. And we end up with minus 2x squared. I suppose technically I've plus naught x plus 1 because we subtract the zeros there, if you like. So minus 2x squared plus 0x plus 1, and you repeat the process. And you keep going until that degree of the remainder is less than the degree of the divisor. So in this case, they're the same. We'll keep going. Minus 2x squared divided by x squared is minus 2. Multiply out. Minus 2x squared minus 2. Do a subtraction. I'm left with a constant number 3. Constant numbers we said were degree 0. That's less than the degree of the divisor. That's where we stop. We've found each of the pieces. It's probably nice to write it as a final statement. They've asked me what is the quotient. Well, the quotient, the answer above the line there, x squared minus 2, and the remainder ended up being 3. Let's try another one. Oh, even further back, 1988. This time it's by x squared minus 3x plus 1. So, same idea. 2x to the 4 divided by x squared is 2x squared. Multiply out. Subtract. Now we keep going. Minus 4x cubed divided by x squared. Minus 4x. Multiply out. Subtract. Yes, we can keep going. Minus 2. Multiply out. Subtract. Now I suppose technically we have answered the question. Because the question simply said, divide the polynomial by this. Well, I've done that. Didn't actually say how they want the answer written or anything like that. But, that's possibly why. Because in part 2, they then said, hence write it in the standard sort of form. So function is equal to divisor times quotient plus the remainder. And so there we go. So we write down our final answer. Now this brings us back to graphing. Now this polynomial division idea is great because if you do it, it tells you a lot about the graph. You just see px on ax, it tells you some information. But qx plus the remainder on divisor tells us a lot more. Okay? So regardless of which form you have it in, of course the bottom of the fraction can't equal 0. They're your vertical asymptotes, you may remember. The qx, when you do the division, that's going to become your horizontal if it's a constant number, or oblique if it's a linear function, asymptote. If it's higher than a linear function, technically it's still an asymptote, could be a parabolic asymptote or things like that. It is possible. It's unusual, but it is possible. Now the top of the fraction, once we've done our division, is interesting. That's where it works out whether it can actually cut that horizontal or oblique asymptote. Remember, you can't cross vertical asymptotes, but it is possible to cut the horizontal or oblique one. It doesn't have to. And how we work it out is we have a look at that remainder. Is it possible for that remainder to equal 0? So let's do this example. It's already been divided for us. Y equals x plus 8x on x squared minus 9. So I know bottom of the fraction can't equal 0. I'll have vertical asymptotes at plus or minus 3. So there we go. Put those in. There'll be an oblique asymptote at y equals x. So we'll draw that one in. Curve will meet in this case. If we have a look at the top of the fraction, 8x, it is possible for 8x to equal 0. So we know the curve will pass through 0, 0. So I'll plot that point in. And that's actually what the curve then ends up looking like. Remember, it'll bend towards the asymptotes, things like that. So we'll just play with polynomial division today. So 4c.